Hey everyone, and welcome. Today we are diving into one of the absolute most powerful tools in your Java toolkit, methods. And forget the dry textbook definitions, okay? We're going to look at this as a way to make your code cleaner, way more powerful, and really the launchpad for building some seriously complex stuff with simple, reusable parts.
You know that feeling when you're coding and you find yourself typing the same lines over and over and over again? Maybe it's a little calculation or printing something out. It just feels repetitive, almost robotic, right? Well, what if I told you there's a way to stop being the robot and start being the one calling the shots?
I want you to imagine this. Instead of cooking the same meal from scratch every single time, you hire a personal chef. You give them a recipe just once, and from that day on, all you have to do is say, hey, make me that dish. And poof, they do it. Perfectly. Every single time. And guess what? That's exactly what we're going to do for our code today.
Now, this personal chef for your code, well, in the world of programming, we call it a method. And trust me, it's a concept that is going to fundamentally change how you write and think about your code from here on out.
So, at the end of the day, a method is really just a block of code that you give a name to. You write the instructions one time, you package it up, and then your program can follow that recipe anytime, anywhere. No need to rewrite the whole thing ever again.
All right, so if a method is a recipe, what's in it? What are the parts? Let's go ahead and break down the anatomy of our code recipe and see how it's all put together. And don't worry, it's way simpler than you think.
We're going to use a super simple recipe for our example today, and we'll call it addNumbers. As you probably guessed, its only job is to add two numbers together. Now, in real Java code, the whole thing might look a little more intimidating, something like public static int addNumbers int a int b. But for now, let's just zoom in on the important part in the parentheses to really get what's going on.
First things first, every good recipe needs ingredients, right? Well, in programming, we call those parameters. They're just the specific pieces of information your method needs to actually do its job. I mean, without the ingredients, the chef can't cook. It's as simple as that.
So for our addNumbers recipe, you can see the ingredients listed right there in the parentheses. We've got int a and int b. You can literally think of these as the two numbers that we're going to hand over to our code chef to work with. They're the inputs, and they're required for the recipe to even work.
Okay, so we've got our ingredients. Now what? Well, now we need the instructions. This is what we call the method body. It's the block of code, usually tucked inside some curly braces, that tells the chef exactly what to do with those ingredients step by step.
The instructions for our addNumbers chef are super simple. First, it takes those two numbers we gave it, a and b. Then it adds them together. And finally, and this part's really important, it gives us back the result, the final sum.
And that brings us to a really critical question. After the chef follows the whole recipe, what do we actually get? Do we get a finished meal, a cake we can eat, or did the chef just perform an action? You know, like preheating the oven for later. So, in programming, that final dish is called the return type. It's what the method actually gives back to you after it's finished running. Remember that whole signature I mentioned earlier, public static int addNumbers? Well, that little int right at the beginning, that's the return type. It's a promise that this method is going to serve up an integer, in this case, the final sum.
Now, not all chefs actually serve a dish. Sometimes you just want them to do something. Our addNumbers method is like asking for a cake. You get a cake back. But a method like, say, preheat oven, it just does the job. It warms up the oven. It doesn't hand you anything when it's done. In Java, we'd say its return type is void. That's just a fancy word for it returns nothing.
So, we've looked at the anatomy of the recipe. We get it. But what's the real payoff here? Why even bother creating these methods in the first place? Well, this is where we go from just, writing code to actually designing smart, really efficient systems.
Just look at this comparison. On the left, we're doing the addition ourselves every single time. It's repetitive. And imagine if that calculation was way more complex. It would be a total mess and a nightmare to update later. But look at the right. We just call our chef. addNumbers this, addNumbers that. It's clean, it's simple, and you know exactly what's happening just by reading the name.
This all boils down to a core principle in software called DRY. Don't repeat yourself. By creating a method once, you're not just saving time, you're avoiding silly copy-paste errors, and you're making your code so much easier for you and anyone else to read and maintain down the line. It's a total game changer.
Seriously, if you take away only one thing today, let it be this. This isn't just about being tidy. It's about building a powerful, maintainable asset. This is the difference between a quick, one-off script and a real scalable application.
So you're no longer just a coder. You're an architect, designing with these awesome, reusable components. You know how to write the recipes now. So the question isn't just how you'll do it anymore. It's what amazing things are you going to build? What will you create?